This small lecturette is a short introduction to units and dimensional analysis. So the idea is we'll look at some common units that are used in science and in chemistry in particular, and we'll look at dimensional analysis, which is the use of conversion factors to convert from one unit to another. And we'll perhaps use density as an example of that. So the common units that we use are length, what's called the SI unit, which is the International System Unit. The base unit for length is a meter. Mass is grams or kilograms. Time is seconds. Temperature is Kelvin. We also use degrees Celsius quite a bit. The amount of a substance we use as a mole. And we are not probably going to do it in this class, but the electric current is done in amps or amperes. We won't use it at all, but the luminous intensity is in candelas, in case you didn't know. Metrics prefixes that go along with those units are things you've seen before, like kilo and deci and centi and milli, micro, nano, and pico. And you have to know these. These are important for you to know all of these ones. And you probably do, but if you don't, you better. Okay, so let's look at some examples, and we're doing this as an example of how to think and how to use units. So let's express 1.75 meters in centimeters. The way you do this is you always write what you know here, 1.75 meters, and be careful about using its units. Leave some space and put an equal sign, and put the unit you want over on the right. Then what you do is you make a conversion factor between the two units you have, meters and centimeters. And the idea is 1 meter equals 100 centimeters, which you knew. Then what you do is, because these two things are equal, a fraction of one of those over the other, in either order, will be equal to the number 1. So you can multiply any initial real quantity of something real, some distance in this case, by that fraction. And the idea is we want to eliminate the units of meters. So what we do is we put that on the bottom. And we want to get the units of centimeters, so we put that on top. Then what you do is when you multiply through, the units of meters cancel, you end up with units of centimeters, and when you multiply the numbers through, you have 175 centimeters. Let's do the next one. 5.8 nanoseconds, that's what we really know. We're going to put times, put an equal sign over here, and we want to get seconds. In case you don't remember the conversion for nano. Woo! For nano, it's 10 to the minus ninth, or 10 to the ninth nanoseconds in 1 second, or 10 to the minus 9 seconds in 1 nanosecond. So we'll put 1 second here. I'll put 10 to the 9th nanoseconds there. So when you do that, it's going to be 5.8 times 10 to the minus 9th seconds, because you take 5.8 and divide it by 10 to the 9th. That would have been equal, to do it this way, an equal conversion factor would have been 10 to the minus 9th seconds over 1 nanosecond. You would have come to the same answer for that. Let's look at units that are not quite the same type, of the not same type. Let's express 458 seconds as minutes. So you take 458 seconds times, you need a conversion factor to get to minutes. And the conversion factor obviously is 1 minute over 60 seconds. And remember, the idea is you want to get rid of seconds, so you put its unit on the opposite side of where it started. And you want minutes, so you put that up on top. So seconds will cancel, and the answer will be 458 divided by 60. And that'll be the answer in minutes, whatever that comes out to. Let's look at how many seconds there are in a day, which will be a multi-step problem. So we have 1 day, and we want to get to seconds. So I'm going to leave a bunch of space here. And what you do is you think, okay, what can I convert days into? Well, days convert to hours, of course. And you know there are 24 hours in 1 day. And what can you convert hours into? You can convert hours into minutes. So I want to put 1 hour on the bottom because I want to get rid of it. And I want 60 minutes on top. And now I want to convert minutes to seconds, which I can now do directly. So there's 60 seconds in 1 minute. And now notice days have canceled, hours have canceled, I need an R for that hour, and minutes have canceled. So now we're left with the unit seconds, and our answer is 24 times 60 times 60, whatever that comes out to, and divided by 1 times 1 times 1, which we can ignore. So remember, the idea here is to use the units to guide yourself from one starting place to where you want to end up. Let's look at a harder example. The distance to the nearest star, Alpha Centauri, or near Alpha Centauri, is 4.24 light years. A light year is the distance light goes in a year, thus the name. Light travels 186,000 miles per second. What's that distance in kilometers? So we have 4.24 light years, and we want to get that. And so what that is, that's how far light travels in a year, and we want to get that to kilometers. So what we want to do is we want to say, let's change that to light seconds. So how many